Students, welcome to our video lecture. We have started the concept of trigonometric equations and we have discussed the solution set of sine function, cosine function and tan function. Let us revise those solution sets. First, solution set of sin x is equal to sin y is x is equal to n pi plus minus 1 raised to n into y, where n belongs to z, and set of zeros of sine function is n pi, where n belongs to z. These students we have already discussed in the last lecture. This is first formula. Second, solution set of cos x is equal to cos y is x is equal to 2n pi plus or minus y, where n belongs to z, and set of zeros of cos function is 2n plus 1 pi by 2, where n belongs to z. Third was solution set of tan x is equal to tan pi. X is equal to n pi plus y, where n belongs to z, and set of zeros of tan function is same as sine, that is n pi, where n belongs to z, and the range of principal solution, the range of principal solution is closed interval 0 to open to pi. Means we start from 0 and up to open 2 pi, because 0 and 2 pi students are the same values. This we have already discussed. Now, today we are going to start from the third sum, which is cot x is equal to minus root 3. Exercise 3.4, third sum, cot x is equal to minus root 3. And then we are going to discuss the fourth sum, where we have cosec x is equal to minus 2. Now, today students, I am going to explain you something which is very important and something which is very, you can say, applicable in your physics as well as chemistry. Very much applicable. Now, we have not written the solution set of cot x and cosec x. I explained, students, in the last lecture. We haven't written the solution set of cot x and cosec x. The reason is cot x can be converted to tan x and cosec x can be converted to sin x. The reason behind this is cot x can be converted to tan x. So we can write here tan x is equal to minus 1 by root 3, and here I can write sin x is equal to minus 1 by 2. I am doing both the sums simultaneously, and for that I have a logic, students, and for that I have a specific reason. For that I have a logic and I have a specific reason. In tan and sine, whenever right hand side is negative, whenever your number on the right hand side is negative, we still convert that into acute 1 by root 3 for angle pi by 6. So minus 1 by root 3 will be for minus pi by 6. So this is written as tan x is equal to tan of minus pi by 6. Now apply the formula tan x is equal to tan y. This value will be y. So general solution will be x is equal to n pi plus y, where n belongs to z. So y is minus pi by 6. So this is to be your general solution. Now we have to also find principal solution. So taking n is equal to 1, we get x is equal to pi minus pi by 6, and that is pi by 6. 6 pi minus pi. Taking n is equal to 2, we get x is equal to 2 pi minus pi by 6, which is 12 minus 1, 11 pi by 6. So the principal solutions are 5 pi by 6 and 11 pi by 6. And this is our general solution. 10 is negative, students. In second and fourth quadrant, all of you know, according to All-STC rule. According to All-STC rule, students, tan function is negative in second and fourth quadrant. Same way for sine also, when your right hand side is negative, always you will still write acute angle. The negative side in sine I get 1 by 2 and pi by 6. So minus 1 by 2 will be for minus pi by 6. So sine x will be equivalent to sine of minus pi by 6. Now compare, your y is minus pi by 6. So the general solution will be x is equal to pi plus minus 1 raised to n. This minus sign I can transfer here and write pi by 6, where n belongs to z. This is the GS general solution. And for principal solution, when n is equal to 1, we will get pi minus 1 raised to 1 is minus 1, minus equals plus pi plus pi by 6, which is 7 pi by 6. And when n is equal to 2, x will be 2 pi. Minus 1 square is plus 1, still this remains minus. So this is 11 pi by 6. All of you know, sine function is positive in first and second quadrant, and sine function is negative in third and fourth quadrant. So, principal solution are 7 pi by 6 and 11 pi by 6. This is our answer, students. So now I hope these sums are very clear. Okay, let us continue with questions 5, 6. We will do at a time only 2 questions. Now, students, let us do questions 5 and 6. The fifth question is cos 4x is equal to cos 2x. Okay, question 5. Cos of 4x is equal to cos of 2x. Okay, and the sixth question is cos 3x plus cos x minus cos 2x. Cos 3x plus cos x minus cos 2x is equal to 0. Condition and instruction is we have to only find GS general solution. What is, students, the common instruction given that we have to find general solution, means only GS. General solution is the solution, students, which is always involving N, where students N belongs to Z. So here directly this is our X and this is our Y. Apply the formula cos X is equal to cos Y. So general solution is 4x is equal to 2n5 plus or minus y. Y is 2x when it belongs to z. So once students we take plus 2x and once students we take minus 2x. And common expression n belongs to z. Transfer this to the left. 4x minus 2x is 2x is equal to 2n5, or transfer this to the left. 6x is equal to 2n5. Common instructions n belongs to z. Here make x as subject of formula. So x is equal to 2n5 by 2. So 2x cancels. So n5. And here it will be n5 by 3. Common instruction belongs to Z. Whenever we have to club the solution set, all is always written in terms of union. In fact, here I have told you the key word for all is union. So the final solution set is n pi, where n belongs to Z, union n pi by 3, where n belongs to Z. This is the final solution set. This is our students' final answer. So students, one has to be very careful. One has to be very cautious in understanding this basics. Okay. Now here what will be done? Cos 3x plus cos x minus cos 2x. Okay, if I club this, c plus c, 2cc. So 2 into cos of 3x plus x, 4x by 2, and cos of 3x minus x, 2x by 2. What is common? Cos 2x. So what remains? Twice cos x minus 1 is equal to 0. Therefore, cos 2x is equal to 0, or 2 cos x minus 1 is equal to 0. Set of zeros of cos comes into play. X, instead of x I have 2x. So 2x is equal to 2n plus 1 pi by 2 when n belongs to z. And here cos x is equal to 1 by 2, and cos 1 by 2 I get it into pi by 3. So making x as subject of formula, this will be 2n plus 1 pi by 4 where n belongs to z. Apply the formula. X is equal to 2n pi plus or minus y. Y is pi by 3. So finally, this general solution to remove all, students, we have to take union. So x is equal to 2n plus 1 pi by 4, where n belongs to z, union 2n pi plus or minus pi by 3, where n belongs to z. So students, this becomes our final solution set. This is, students, our final solution set. Now Students, now we go for sum number 7 and 8. Let us do sum number 7 and 8, students. Seventh sum, sine of 2x plus cos x is equal to 0. Okay. Sine of 2x plus cos x is equal to 0. Okay. So we have two functions in the same equation. Now students, sine of 2x can be written as 2 sine x cos x. All of you know this. So 2 sin x cos x plus cos x is equal to 0. Take cos x common. So cos x into 2 sin x plus 1 is equal to 0. Then cos x is equal to 0. Or sin x is equal to minus 1 by 2. Cos x is equal to 0. Apply the set of zeros of cos. So 2n plus 1 pi by 2. Where n belongs to z. It will replace negative value by acute angle only. But with the negative sign, in sine we get 1 by 2 at pi by 6. So minus 1 by 2 at minus pi by 6. So apply the formula sin x is equal to sin y. So x is equal to n pi plus minus 1 raised to n into y. Y is negative sign. So minus y is negative sign. So final general solution set will be x is equal to, take union, 2n plus 1 pi by 2 where n belongs to z union n pi minus 1 raised to n pi by 6 where n belongs to z students. This is your final solution set. Okay, let us do sum number 8. Sec square 2x is 1 minus is equal to 8 sum. Sec square 2x is equal to 1 minus tan 2x. Now, all of you know that 1 plus tan square theta is equal to sec square theta. So sec square 2x is written as 1 plus tan square 2x. 1 and 1 gets cancelled. In trigonometric equation, never cancel trigonometric terms. So tan square 2x plus tan 2x is equal to 0. What I told students, never cancel trigonometric terms. Constant definitely students we can cancel. What is common? Then the answer is tan of 2x. So what remains? Tan 2x plus 1 is equal to 0. So a into b is equal to 0. Therefore, tan 2x is equal to 0. Or tan 2x plus 1 is equal to 0. So tan 2x is minus 1. Apply set of zeros of tan function 2x is equal to n pi, where n belongs to z. In tan we get minus 1 at minus pi by 4. So tan x is equal to tan y. So twice x is equal to pi plus y. where n belongs to z. Make x the subject of formula. So n pi by 2 where n belongs to z, or x is equal to n pi by 2 minus pi by 8 where n belongs to z. So finally the general solution will be n pi by 2 where n belongs to z union n pi by 2 minus pi by 8 where n belongs to z. This is how we have to do the sums of trigonometric equation. That table which we have already done must be done again and again, because you should know the range of sine, cos and tan functions, and you should know set of zeros of sine, cos and tan functions. Now last sum of the exercise students remains, that we will complete the exercise. Now students, we are doing the last sum of exercise. Sin x plus sin 3x plus sin 5x. Okay. Now students, what can be thought for the sum? What approach directly comes to your mind while doing the sum? Then the logic is here. Apply s plus s, which will give you the middle angle. This type of sums we have done students in exercise 3.3. So grouping like this, sine of 5x plus sine of x plus sine of 3x is equal to 0. Now s plus s is 2sc. So 2 sine of 5 plus 1 6 by 2 so 3x, cos of 4x by 2 so 2x plus sine 3x is equal to 0. Taking sine 3x common, 2 cos twice x plus 1 is equal to 0. Therefore, sine 3x is equal to 0, or cos 2x is equal to minus 1 by 2. This is of much importance. We revise again and again. For sine and tan, if your right hand side is a negative number, we are going to convert it into acute angle only. But for cos, if your right hand side is a negative number, you have to write it as obtuse angle. In cos, we get 1 by 2 at pi by 3. So we will get minus 1 by 2 at pi minus pi by 3. If it was minus 1 by root 2, pi minus pi by 4. And if it is minus root 3 by 2, it is pi minus pi by 6. This is fixed. So minus 1 by 2 is modified as pi minus pi by 3. And that is 1 by pi by. So here, set of zeros of sine function 3x is equal to n pi, where n belongs to z. And here 2x is equal to 2n pi plus or minus y. Y equals to pi by 3. Making x as subject of formula, this changes to n pi by 3, where n belongs to z, or x is equal to n pi plus or minus pi by 3, where n belongs to z. Finally, the general solution set Px is equal to n pi by 3, where n belongs to is there union n pi plus or minus pi by 3 where n belongs to z. So this is how students we do the sums of trigonometric equation. Remember three important things. The first, you should know definitely the solution set of sine, cos, tan, and solution set of cosec, sec and cot does not exist because we can convert the functions into sine, cos and tan. Point number two, you should know the set of zeros of sine function, cos function and tan function, as well as its range. Range of sine and cosine function is closed interval -1 to 1 and range of tan function is pi. Third important thing, in sine and tan, if your right hand side number is a negative, we still modified it in terms of acute angle only. The reason is inverse t function which we will study in 12th standard. And if in cos your right hand side is a negative number, you will modify that number in terms of a cos theta term, where theta will be an obtuse angle. The reasons for this are studied in 12th standard for inverse trigonometric functions. So this three important concepts you have to remember. Last point, once again I am reiterating. If your right hand side is a negative number in sine, write acute angle with a negative sign. If a right hand side is a negative number in tan, write a negative number as an acute angle with a negative sign. In cos, if your right hand side is a negative number, modify it into a cos theta term where theta is an obtuse angle. So here we conclude exercise 3.4. Remaining we will do in the next video. Thank you, students.